Welcome to EDU World Space.
Hello and welcome to Chapter 1, Problem number 22 in Physics for Scientists and Engineers with Modern Physics. So this problem is going to be very similar to the last problem we did. However, this time we're really only going to be using variables, we're just going to be solving for variables with no actual given values. So this problem asks us to write the radius of an aluminum sphere in terms of density and the radius of an iron sphere, given that the masses of both of these two spheres are the same. It's kind of a lot to talk in, so let's just do it step by step. So right off the bat, we are going to be talking about density, rho. We're going to have rho is equal to mass over volume, and more specifically, this question is about the volume of a sphere. And so the volume of a sphere is 4/3 pi r cubed. So I just threw that in the denominator here, just substituted it in to have a specific rho equation for our problem. And so really that's pretty much all the preliminary stuff we need to get out of the way. This entire problem is going to really be based on this equation here. The mass of this iron sphere is going to be the same mass of this aluminum sphere. And so what we do here is we rewrite our rho equation in terms of mass. So just multiply the denominator over, and we plug that in to these two down here, mass of iron and mass of aluminum. So bear with me here. You will see that the density of the rho of iron is going to be times 4/3 pi times the radius of that iron sphere cubed is equal to the same thing for aluminum. The density of aluminum times 4/3 pi times the radius of that aluminum cubed. And this radius here, that is what we're going to be solving for. So at this point, it's just going to be algebra solving for this r. And so right off the bat, we can see that they both have this 4/3 pi. It's a constant term. So we're allowed to just cancel it on both sides of our equation. So we'll have rho Fe times r Fe cubed is rho aluminum times r aluminum cubed. So at this point, we bring our rho's over, and then we take the cube root. So we'll have, r aluminum cubed is this fraction here times r of iron cubed. So when we take the cube root, we'll get the final answer for this problem is the radius of the aluminum sphere is going to be the cube root of the density of iron over the density of aluminum. So that quantity cube rooted times normal radius of that iron sphere. Since we had a cube, it's not cubed down here.